we are discussing about the total differential equations, and then here the standard format of the total differential equation is the pdx plus qdy plus rdz equal to 0, where p, q, r are functions of x plus z is called a total differential equation. See here is a total differential equation. Pdx plus qdy plus rdz equal to 0. The necessary and substitute condition for integrability of single differential equation pdx plus qy plus rdz equal to 0, where p, q, r are functions of x plus z is p into dou q by dou z minus dou r by dou y plus q into dou r by dou x minus dou p by dou z. Just you see here p into plus q into plus q r into equal to 0 you are getting here. Now, just if you write the first component, the remaining thing you can write easily by replacing P by Q, Q by R, R by P. Similarly, in the cyclic order, similarly Z by X, X by Y, Y by Z, Z by X. That is in the by writing in the cyclic order, replacing one by the other in the cyclic order, you will get this condition that is called the exactness condition. Okay. Now, after that, here just to see. The condition for the exactness. You see the condition for the differential to be exact are dou q by dou y equal to dou q by dou x, dou q by dou z equal to dou r by dou y, and dou r by dou x equal to dou p by dou z. Okay. Now already we have discussed the general method. What I have to do, you see there are five steps are there. First step is verify the condition of integrability. Before going to that, you have to verify the given equation is of the form p dx plus q dy plus r dz equal to 0. That is the standard form of total differential equation where p, q, r are functions of x, y, z. Okay. Verify the condition of integrability. That is the first condition. You have to verify this condition. What have taken p into plus q into here. You see here, this is to be satisfied. Then only you can move for this working rule. Okay. Now, when the condition of integrity is satisfied, that means this condition is satisfied, then you take any one variable as a constant. Of course, they are taking all the cases there as a constant, and that dz equal to 0 you get, because z equal to constant means you get dz equal to 0 by differentiating and integrate the remaining. The given equation will become dz equal to 0 means 0 into r is 0, pdx plus qdy equal to r0 you are going to get. Now after getting that one, we have to here you have to integrate. Okay, you have to integrate, so that we'll get here the phi of x y equal to f of z, where f of z is an integral constant. Okay, you see you are taking z as a constant, that's why you are writing here f of z. If you take x as a constant, you can write f of x. And one thing you remember here, there is no need to take z as constant always. Okay, f of z as a constant of integration, you can write f of x is equal to constant. If you take y is equal to constant, you can take cy equal to 0. Now, D, differentiate. The fourth step is differentiate of x y equal to f of z. You see, this is the main one here. What I got in the third step, there is the main one. And here, after that, we have to find out the value of f of z. That means you differentiate totally with respect to x, y, and z, so that compare with the given equation, so that the remaining will become the equation containing the variables f of z and z. Solve this differential equation to determine f of z. What you got the step that is containing f of z and z, how to differentiate. Substituting this in of x equal to f of z to get the required solution of the given equation. Okay. Now already you have seen first one, then you got the second one. Here you got the third one. Here, third one is over. Fourth one. Now we'll see here the fifth one. Okay. This is the fifth one. Now verify the condition for integrability and solve 2x square plus 2x square plus 2x z square plus 1 into dx plus dy plus 2z dz equal to 0. Okay. Now here you see, if you take x is equal to constant, because you see now in the previous cases you have taken there z is equal to constant and then you got dz equal to 0. Okay, z is equal to constant and dz equal to 0. Now, but here you are taking x is equal to constant, then you are writing here the x equal to 0, because x equal to constant in the sense x equal to some k, you can take with k is a constant. If you differentiate x equal to k, you get dx equal to 0. Okay. Now, to go for the given equation, you see dx is 0 in the sense this 0 into this entire thing, the first component will become vanishes. The remaining equal to dy plus 2z dz equal to 0. Integrating this, you are going to get a y plus z square equal to f of x. So see, in the previous cases, what you are taking in the working rule, there you are taking f of z as the uh, integral constant. But here you are taking f of x because we are taken here x as the variable. And one thing here you see, verification of the integrability condition is not, we are not done this, but this is to be done by taking that condition. What is the p into the q by those that equal to what they are the same, you have to write here. You have to write and we have to verify that condition. And here we have to verify p dash plus p dy plus r is equal to 0. That's standard form. Then integration of integrability, condition of integrability. Then x equal to constant means you are taking here the x equal to 0. That is differentiating. You're getting the x equal to 0. Now dx equal to 0 means the first component get vanishes. The remaining is equal to dy plus 2z dz equal to 0. Integrating, on integrating you will get here y plus z square equal to f of x. Actually f of x we are getting integral constant c that we are replacing by f of x because x is the constant, so we are taking it f of x. In the previous cases you got the z is the constant area of z there you are. Now creating the constant of integration as a function of x, you can write to p y plus z square minus f equal to 0. F in the sense f of x, because there is no need to write f of x here. If you write f, that itself is indicates that f is a function of x. Okay. Now differentiating totally with respect to x y z. If you differentiate, you get here this d into f y dy 2z dz minus f dash of x into dx minus f dash of x into dx. Now, differentiating totally, you are getting this, comparing this with the given equation. Okay, you have to compare this with the given equation. You see, dy plus 2z dz minus f dash of dx equal to 0 is there. The given one equal to dy is there, 2z dz is there. It's not. Now, the remaining is that is you are getting here. Minus f dash is the coefficient of dx, and dx coefficient in the given equation is the given equation 2x square plus 3x square plus 3x square plus 1 that is the coefficient in the given equation. Now if you equate those two that we are getting here, that is equating the coefficients of f of x and from the given equation, and then from the given equation, and then comparing this with the given equation or getting this. Already you know f dash in the sense of the f by dx. Now here you see 2x square plus 2x into y plus z square, y plus z square plus 1 equal to minus df by dx, minus df by dx. Now if you simplify further, you are going to get the linear equation df by dx plus 2x because y plus z square equal to f is there. That's why you are writing here. This is your replacing by 2x and remaining you are writing equal to minus 1 plus 2x square. Now, this is a linear equation of first order. Already you know how to solve the linear equation of that is linear differential equation. Integrating factor we have to write first. If dy by dx plus py equal to q is there, then you are writing integrating factor equal to e to the power integral p dx you are writing. You see, if you compare this with dy by dx plus py equal to q, p equal to 2x you are getting here. The same you are done here. Integral p dx you are writing here. Now, if you integrate this, you go to x square by 2x. If you integrate with x square by 2, 2 get cancelled here only x square. That means you got here integrating factor equal to e to the 4x square. Okay. Now it is solution. Yeah, so the linear format is there. The dy by dx plus py equal to q is there. All right. Y into integrating factor. Here y instead of y, we have here f. F into integrating factor equal to, you have to write the integral sign, and here you have to write a q. What is q here? E to the power x square. Okay. Integrated factor into q, the minus 1 plus 2 square into integrating factor with respect to x plus c. You have to write that is the solution of linear differential equation. First you have to write the integrating factor, then you have to write the solution as first to dy by dx plus py equal to q plus y into integrating factor equal to integral q into integrating factor with respect to x plus c. You are writing that is the linear equation for that is the solution for dy by dx plus py equal to q. Okay. Now the same you can write as this f of e to the power x square equal to minus 2 into so on. So you can write. Okay. After writing that, here just to take here how to do some modification, and I have to find out the solution to get First you take here 2x e to the power x square dx by putting x square equal to t, you take here. If you take x square equal to t, you are going to get e to the power t dt equal to e to the power t, you are getting here integrate. And now e to the power t means you can replace t by x square, e to the power x square you are getting. This is the integration of 2x into e to the power x square dx. You are writing here. This is an integration you are getting here e to the power x square. Why you are taking means here you have to simplify this expression. That's why you are writing that. Okay. Now after getting that, you see here write 2x square e to the power x square dx is there. 2x square e to the power x square dx is there. Now you keep x one side, x as x into the remaining thing you can add here. Here x into 2x e to the power x square dx are getting here x into integration of 2x e to the power x square. You see here the value of e to the power x square 2x dx and the integral sign equal to the power x square. That means you are adding x into by integrating factors by integrating by parts you are adding here x into integration of this you are getting minus sign integration of the equal to this and the differentiation of x equal to 1 into dx you are getting here. Okay. Now to shift this minus sign containing expression to other side we are getting this. Now the same here you see why you are writing means if you add these two you are getting this. That means here you can replace these two entities by that quantity what are taken that is you can replace by x is the for x square because you see here by adding this with this you are getting here the same x e to the power x square. Okay, x e to the power x square. Yeah, of course, here you get the minus sign. Here you get the minus sign. Here you get the minus sign. And minus into you are writing here. Minus the same you can write as here. The same equal to x e to the power x square. By simplifying this, you are writing here. Now, what you got here? Integration of e to the power f into e to the power x square. Here, first what you got here? F into the power x square. It is there. There is no integral sign here. It is a mistake here. You see here you got here f into e to the power x square equal to c minus x e to power x square you are getting here. Okay, this is not integral. This f into is there. Okay, now what you got here? You keep f. This is a print mistake here. Okay, now here f of x equal to c into e to the power minus x square minus x. That is dividing throughout by e to the power x square. You are getting this by f of x equal to. Now, the solution of the given equation is y square plus z square equal to c into e to the power minus x square minus x. Because you see, what is the f of z containing, you see, after simplification, you got somehow y plus z square equal to f of x you got here. You see, this is the main one. Here you have to find out f of x. In the previous cases, you have taken f of z and you have simplified the term containing f of terms containing f of z and z and you are writing here. Here f of y plus z square equal to f of x. You got the value of f of x here. What is the value of f of x here? C minus x e to the power x square. Okay. Now, the solution of the given equation is y square plus z square equal to c e to the power minus x square minus x. Now minus x you can shift to the other side and you can write x plus y square plus z square equal to the same. Okay. Now the same problem you can do in another way. Okay. That is just to see here alternate method here to see the given equation. First you already the given equation and then here you have to group the terms. That is the way you have to by grouping the terms you're going to get a solution or integration. Now just you see here you take this one is there. You see here four components are there. 2x square, 2x square, 2x square plus 1. Now keep first three terms as it is and you multiply with the dx. Okay, and 1 into dx you write as separate component. Okay, you write here 2x square plus 2 plus dx plus dy plus 2z dz. Now the remaining thing you take 2x as common from first three components of coefficient of dx, so that you get 2x into y plus x plus y plus z square dx plus dx plus dy plus 2z dz equal to 0. Now just you see here dividing through by x plus y plus z square. On dividing this by this, just you are going to get here. This get cancelled, getting 2x dx plus d of x plus y plus z square by x plus y plus z square you are adding here because this is the numerator we're going to get here. If you differentiate, you get dx plus dy plus 2z dz. You are getting that's why you are adding a d of you are adding. That is the differential you are adding here. Okay. Now after getting that, you integrate. If you integrate x x square by 2 you are going to get, because integration of x to 4 n is x to 4 n plus 1 by n plus 1. Okay, that's why you are writing here x square by 2. 2 2 get cancelled, getting here only x square plus log of, here you see x plus y plus z square you are getting, because you see dt by t you can write as log t. Here t equal to x plus y plus z square. After writing a log x plus y plus z square equal to log c. That is the integral constant you are writing here. Okay. Now the same x square you can write as e to the log e to the power x square you can write log e to the power x square. Okay. Now here log m plus log n you can write as log mn, and again replace removing log on both sides, so that we will get here x plus y plus z square equal to c into e to the power minus x square. Okay, that is the case. Now with this, now what you are filled here, you see first you are taken the total differential equation in exact form, then what is the total differentiation in exact form, you see here. First we have to write p dx plus q dy plus r dz equal to 0 format is there or not, that we have to identify. After getting that, we have to go for the condition of integrability. The condition of integrability, p into you are taken plus q into plus r into what are taken as that will become equal to 0. Okay. Now just like in the previous list what are taken there, you see that here the condition is, it's the condition. You see here, P into plus Q into plus R into is there. That will become 0. First is P dx plus Q dy plus R dz equal to 0. That is the first condition, where PQR functions of x, y, z. The second, this condition must be satisfied. After satisfying that, means this is equal to 0, you have to get. After getting that one, you have to go for this condition. Okay. Now, what I have to do after that, just you have to take one variable as a constant. And then here, you are taking z as a constant, will be z equal to 0, and dz equal to 0 means the given equation you have to write. After writing that, you have to integrate. After integrating, you get integral constant. That is integral constant. If z is a constant, you have to take f of z. If x is a constant, means you have to take f of x. Okay. Now after taking that, you have to, we will get the value variables containing f of z and z. That we have to f of z and z, that we have to differentiate. Okay, that is first here. This is here. This is here totally differentiating. You see first here condition is over. Dz is 0. The given equation will become 1. So after integrating, you are getting integral constant, you are replacing by f of z. After getting that, we have to find out the value of f of z. Okay, after getting the integral constant, you are taking as f of z. Now, now after you got that one, the what you got, that you have to simplify, and here you have to differentiate totally with respect to x plus z, so that you will get the variable containing f of z and z, that you have to differentiate either by linear differential equation, means you have to follow the working rule of the linear differential equation, or the variable separable form, variable separable, whatever may be the way, you have to find out the f of z. After getting f of z, after getting f of z, that you have to substitute in u of x y equal to z. That means here you see what you got here. You see here, you got here this y into x plus z by y plus z equal to c. This c is replacing by f of z. That f of z is replaced by, so what you got here, the value of f of z. F of z equal to, got here c. That's why you're writing y into z plus x equal to y plus z into c. You're writing. Okay. Just substituting f of that value. Okay. That is the case that you got the total differential equation. The main one is the p dx plus q dy plus r dz equal to 0 form. The second condition is to be verified. You have to take the variable as a constant, and then you have to, oh, or you have to substitute in the given equation. After substitution, you get the equation containing x and y. After substituting, you get the x and y dx dy. You have to integrate. After integrating, you get the integral constant, that you have to replace by the constant of z. After getting that, you have to further totally differentiating with respect to x plus z, and you have to compare the coefficients of dx dy dz in the given equation, as well as equation that we got by differentiating totally with respect to x plus z, so that you get the equation involving f of z and z, that you have to find out the value of f of z. After getting that one, here you have to substitute. Where you have to substitute there, you got u of x y equal to f of z. That is what is there. You got integral f of z, where you got there, that you have to write u of x y equal to f of z. That is given. You got the solution. Okay, by replacing f of z, you will get the solution. Okay. Just to go through the working rule. You see here the main, here you have to know the working rule. Here you see the working rule is, the working rule. There are five steps are there. You see a general method of integrating PDX plus QDY plus RD is equal to 0. This you refer and you do the problem so that you can get the idea. And one thing here, the exactness also you can use and you can do the problem. You see the first one, you see by using the fact of exactness, you are right, you are finding the solution here. Okay. That is also the case. And one more here you see P dx plus Q dy plus R dz is equal to 0 is the P into dx is there. That means don't differentiate P with respect to x here. Differentiate P with respect to y as well as z. And here Q dy, P dx plus Q dy plus R dz, Q into dy is there. Don't differentiate Q with respect to y, but differentiate Q with respect to x as well as z. Similarly, here also R dz equal to 0 is there. Don't differentiate R with respect to z, but differentiate R with respect to x as well as y. That is the case we have to that we are going to use in the condition of integrability. Okay, those differentials are in existence. It is existing and condition you can verify there. Okay, that is you have to find out the partial derivatives. What is meant by partial derivatives means to see if the independent variable is more than one is there, then that will be called as partial differential equation. Okay, the equation containing more than one variable, then you can differentiate and get the partial derivatives. If it is a single variable, y is equal to f of x is there, you get the derivatives, dy by dx, d square d square y by dx square, d square dq y by dx square, etc. But here we get dou y by dou x, dou square y by dou x square, etc. We get there. That is the case of getting there. That is the difference between the partial derivatives and then the ordinary differential equations. Now we'll go for the next one, simultaneous equations. Okay. Now the differential you see here is the simultaneous equations. The differential equations of the form dx by p dy by q equal to dz by r. We are calling as equation number one. Okay. Just should remember is the standard form of the simultaneous equations. Simultaneous. The previous one is what? The previous one is the total differential equations. Now what are discussing simultaneous equations? Okay. Here, where P, Q are functions of x, y, z, same condition are called the standard form of the simultaneous equation in three variables. Okay, what are the variables? X, Y, Z are the variables. Okay. Now, solving these equations means finding two independent solutions. U1 of x, y, z equal to C1, U2 of x, y, z equal to C2 of the equations. Okay. Solving these equations means you have to find out two solutions that are U1 of x, y, z equal to C1, U2 of x, y, z equal to of x y z equal to C2 of the equation. Now, two functions u1 and u1 of x y z and u2 of x y z in the mistake this u2 here are said to be independent if u1 by u2 or u2 by u1 is not merely a constant. Okay. For example, if you take u1 equal to x square plus y square plus z square and u2 equal to x minus y plus z are independent, whereas the functions u1 equal to 3 plus 3y plus 3z and u2 equal to 5x plus 5y plus yz are not independent. Because you see, if you divide one with the other, we have to get the constant means. So if you get the constant, then you can say they are the dependent one. If you do not get the constant, then that will be called as independent, and that is called the that is independent solutions. They are not independent dependent. Okay. That is u1 by u2 equal to some constant or u2 by u1 equal to some constant. You can say they are dependent one. If it is not so that that the constant is not existing, you can say they are independent one. Here we are going to get the independent solutions. Okay. Now method of grouping. The first method here in case of simultaneous equation. What is the standard form here? dx by p equal to dy by q equal to dz by r. This is the standard form. Okay. Now method of grouping. There are two methods are there. First method is method of grouping. Suppose that one of the variables can be cancelled or it is absent in two fractions of one. Then the solution of the equation formed by these two fractions can be obtained by means of solving the equation of first order and first degree. This gives one equation of the complete solution. Again, if it is possible to see any one of another variables can be cancelled or is absent in different set of two fractions of one. Similarly, we can get find another equation of the complete solution. These two solutions taken together constitute the complete solution. That is the method of grouping. Okay, just remember here, if you take two variables, how many variables are there? You are discussing only three variables. Out of three variables, if one variable is constant, how many possibilities are there? Dx by p, dy by q, dz by r. I think you got three options are there. Either you can take one and two, or two and three, and one and three you can take. The three options are there, but here you have to choose in such a way that the variable is constant or it is cancelled. Then you can take the, if you take two fractions, if there is, if that is not existing, there is a, or there is cancelled, or it is absent in the first two fractions, or second two fractions, or first and third fractions. You can say you can find out that is three set out of three sets. You have to get two independent solutions. You have to get, okay. What, take one and two, then you take two and three, then you take one and three. Out of those three, you have to get any two independent solution. Then you can say that that is those two containing together. If you take that, it will be the solution of the given equation. Okay. Consider the first two fractions. Okay, because you see here, dx dy. This is by inspection you are writing here. You say if you take first and second, z get cancels. The remaining is containing only x, y terms are there. Differentials and then the expressions are x and y are there. Okay. Now here consider the first two fractions. Dx by y square z equal to dy by x square z, which implies here z get cancelled. Getting here dx by y square dy by x square. If you cross multiply, then you will get in here x square dx minus y square dy equal to 0. On integration, you are going to get x cubed by 3, because you know x to the power n integration with respect to the dx is given by x to the power n plus 1 by n plus 1. That's why we are writing here the same. Here also the same, y to the power n plus 1 by n plus 1 equal to, you are getting here some constant, integral constant is equal to c. Here the first one you are getting, that's why we are writing here c1. Okay. Now what we got here totally, here we are getting x cube minus y cube equal to 3c in the sense that equal to, you are taking c1. Okay. Now you got one solution. This is by casting the terms. Casting the terms. Again consider the first and third ratios. Okay. Now if you take second and third, it is somewhat different. There is x, y, z, three are involved here. But if you take the first and third ratios, you can write dxy, dz. Here you see y square that comes remaining containing only the x and x and z, and the differentials of these x and z you are getting here. Now you write the remaining thing y square by cancellation of y square, you get here the x by z equal to dz by x, and then here on integration you are going to get here x square by 2. Again you see here x dx minus z dz. You cross multiply and you write, you can get here this. Now here x square by 2 minus z square by 2 equal to c dash. Of course here we're getting here c c2 c dash in the sense 2 c dash equal to c2. That is, now how many you got here? Now here you got two independent solutions you got here. That is u1 by u2. That is, this is one u of x by u1 of xy is this, u1 of xyz, u2 of xyz is the second one, that is equal to c2. Now 1 and 2 taken together consider the complete solution. That is the case. Now what you are using means that is one term is cancelled in two fractions, taken two fractions. That's why here both the methods are involving here by taking that is what you are taking by cancelling the term you are writing here. Okay. Now, the second method is method of multipliers. Method of multipliers. By choosing proper functions p1, q1, r1 of x, y, z, we can write dx by p, dy by q equal to dz by r equal to p1 dx, p2 dy plus p2, that is r1 dz divided with p1p, q1q plus r1r. That means here you are multiplying the numerator here by p1 dx, means the same you have to multiply with the denominator also. P1 dx divided with here p1p. P2, if you write here q1 dy means q1q you have to multiply. Here r1 dz means r1r you have to write, and you have to add r, and I am writing this. And one thing here you see here, if you p1 q1 r1r, you have to choose in such a way that p1p plus q1q plus r1r equal to, that means the denominator must vanish. Then only you can go further the method of multipliers you can write. That is the way of write here. Now, solving this equation gives u1 of x y z equal to c1 as a part of the complete solution. Okay, that means we are choosing p1, q1, r1 in such a way that the denominator q1p plus q1q plus r1 are equal to 0. Similarly, the second set you are going to get here. Again, you are taking another set of functions and you are writing here p2, q2, r2, or you have to take, and then here you have to write p2 dx plus q2 dy plus r2 dz divided with p2p plus q2q plus r2 are equal to 0. That is r2 r is not right. The denominator must become 0. That is p2p plus q2q plus r2 are equal to 0 means we get here p1 dx to p1 p2 dx plus q2 dy plus r2 dz equal to 0. Now these two solutions constitute the complete solution of the given equation. Okay, one solution is u1 of xyz equal to c1. Second one is u2 of xyz equal to c2. Now the functions p1, q1, r1 or p2, q2, r2 are called multipliers, and the method is called method of multipliers. What are the multipliers here? The multipliers are p1, q1, r1, p2, q2, r2. They are the multipliers. First one is method of grouping. This is the second one, method of multipliers. Okay. Now here we'll take one problem. You see here. You see this is by observation. If there is no change in the okay, otherwise we have to go for trial and error method by seeing the expressions. Okay. First, if you take here you're taking 1 1 1 as a multiplier. 1 1 1 as multipliers. Now, if you take 1 1 1 as multipliers, each fraction is equal. Each fraction means you see there are three fractions are there. You see this is one, this is second one, this is third one. That is each fraction is equal to first 1 1 1. That is 1 into dx plus 1 into dy plus 1 into dz. And I am told to you method of multipliers means the same you have to multiply the denominator 1 into. If you expand, you get this. The denominator will become 0. And on cross multiplication, you will get here dx plus dy plus dz equal to 0. On integration, you will get here x plus y plus z equal to c1. Okay. That means here you have to take 1 1 1 as multipliers that you have to identify by trial and error method. If you know, then that will be okay. Now again, you have to find another solution. You take here 1 by x, 1 by y, 1 by z as multipliers. Okay, so here the same way. If you take here each fraction is equal to 1 by x into dx plus 1 by y into dy plus 1 by z into dz. The same you have to multiply the number 1 by x into x means x is cancel get here y minus z. 1 by y into dy plus y here will get here. 1 by y means y get cancelled z minus x plus here 1 by z into means x minus y. Now if you simplify further, you are going to get that is equal to 0 here. 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. Now we have to integrate. If we integrate, we get here log x plus log y plus log z equal to 0. Log z equal to log c2. That is the integral constant we have to. Because here all are the logarithm is there. We take here also log c2. Now log m plus log n plus log r you can write as log mn or you can write because log m plus log n you can write log mn you can write x y z equal to c2. And the solution of the given equation Hence, the solution of the given equation is x plus y plus z equal to c1 and x y z equal to c2. Now you got two solutions. In solving equation number 1, sometimes use both the methods mentioned above to get the two independent solution of the given equation. That means we can use either one method, that is the method of grouping or method of multipliers, or we can use both the methods for solving or to get two solutions. That is the case. Okay, it is not necessary to use only one method. You can apply both the methods for one problem, or you can use separate which you got here separately and use that method of multipliers or method of grouping, or you can use both the methods for solving this. That is, you have to get two independent solutions, okay, not dependent. Already you know u1 by u2 equal to, now to it is not possible to get the constant, then you can see they are the independent one. Already discussed about that. That's it. Thank you.